JANZZ.technology, the podcast.
Hi everyone, welcome to a new episode. To tackle today's topic, how to generate useful data for job matching, I have with me Alejandro Jesus Castañeira Rodriguez, our principal data scientist.
Hi everyone, thank you for having me.
At JANZZ.technology, we are dealing with occupation data every day, and Alejandro is our go-to person when it comes to innovative approaches and data analysis. Alejandro, please, tell us a bit about your job. What do you do as a principal data scientist at JANZZ.technology?
As a data scientist, I work through all the stages of the product development cycle, starting with data collection as we collect our own training data to train our deep learning models. This is done in a Swiss way, where we have specialized domain curators who collect data on a daily basis, where I help organize and monitor this process. Once the data is collected, I clean and normalize it, and after that, I perform the training of our deep learning models for the human resources domain. A big part of the work consists of constantly keeping our technologies on par with the current state of the art. So I constantly research new deep learning models and try new architectures. I also work in other areas of the development cycle, such as the deployment and maintenance of our services. Also, some of our business-to-business customers have very specific and complex requirements, so I assist them by developing customized APIs to meet their needs.
Our topic today is how to generate useful data for job matching. Can you give us an example of useless data?
For example, the raw text of a job description, a resume, or a profile from an HCM system. If it's not structured in a useful way, then it's just text. So if you use data like this for comparison, you will basically just be comparing text against text. Also, in this case, you will get a lot of noise. So there are some strings that are not relevant at all for the comparison.
How is a text-only or say text-based approach not useful when it comes to comparison?
Well, sometimes completely different words can be used to describe the same occupation, education, or skill, etc. And they all refer to the same concepts. So these words are semantically the same, or at least related. In a text-only approach, these kind of relationships are lost. There are many partial relationships that might be overlooked in a text-based approach. For example, an occupation such as software developer carries some relationships with Java front-end specialists, even if they are not exactly the same. Java front-end specialists are more specific, but there are still some competencies that both occupations have in common.
Following this example, Alejandro, what innovative approach did JANZZ.technology come up with to capture such relationships of common skills?
Well, Java front-end specialists and software developers are both concepts in our knowledge graph, or ontologies, as we call it. So we can estimate the degree of similarity of these two concepts by the relation that they share on the JANZZ knowledge graph. Then we transform the job advertisement, candidate resumes, or a profile from a human capital management system into a structured and explainable representation composed of these ontology concepts. At JANZZ.technology, we have developed a structure where we store competencies such as occupation, skill, education, etc. in a vector we call JANZZ. Don't confuse it with the name of our company. We can compare then these vectors between candidates and jobs to get a match score. It is good to note that in the JANZZ vector, we only store the job-related attributes. So other factors such as gender, nationality, ethnicity, etc. are completely discarded.
It's interesting that you mentioned that. Can you clarify why it's so important that the matching score doesn't take those irrelevant factors into account?
They aren't used for matching because at JANZZ.technology, we believe that anonymized procedures at the very beginning of the job application process can largely reduce discrimination and bias and improve equal opportunities. Transparency is paramount to ensuring that AI is not biased, and we see the growing importance of this reflected in the increasing number of regulations and guidelines in the European Union regarding the subject of explainable AI. The regulation focuses strongly on avoiding unfair bias when AI software is deployed in production. In this sense, AI systems which are designed to replace or guide human decisions should be fully explainable, and each prediction made by this system should be fully traceable and transparent. One of the important regulations entitled by the European Union is the right to explanation. This right primarily refers to the right of an individual to be given an explanation for decisions taken by an algorithm that significantly affect them legally or financially. Our company, we have developed our matching system in a way that is fully compliant with all the European Union's regulation. It is completely explainable, transparent, and interpretable. And you can describe in a granular detail how a matching score is produced, which skills, education, etc. a candidate is missing for a given position, or how many years of experience are still required, and so on.
How does JANZZ.technology transform job ads, resumes, or a profile from an HCM system into this structured and explainable form?
To generate this structure, JANZZ has developed its own parsing system that is able to process several document types in multiple languages and transform them into a structured representation. This system uses a combination of natural language processing methods and several deep learning models that have been specifically trained to process human resource data.
Alejandro, you mentioned using machine learning in data processing. Can you tell us more about it?
Yes, we apply deep learning and AI methods in some of our processes, but I think it's important to notice that the main objective for us within the use of this technology is to recommend, say, better candidates to vacancies or employees to projects or training initiatives within enterprises in much less time, but with the final hiring decision completely made by humans. So the main objective of our deep learning and artificial intelligence methods is to get rid of human intervention, but to empower it. For this purpose, at JANZZ.technology, we have developed a unique and patented end-to-end recommender system in the HR field.
Can you explain a little more about this end-to-end recommender system?
Sure. This system comprises a series of natural language processing techniques and deep learning models to achieve a fully automated process that will propose semantically related and explainable suggestions to job seekers and companies in real time. The architecture of the system combines the JANZZ ontology with several NLP techniques like name-entity recognition, text classification, and entity relationships based on HR data collected by domain-specialized curators. And it also includes language detection, specific text preprocessing, and language model pre-trained over domain-specific data, which allows the system to extract and process more than 50 different characteristics from job posting and resumes, such as occupation, skills, education, etc., with various levels of granularities across multiple languages.
And just to clarify, all this training data is gathered by people?
Yes. As I said before, all data used to train this model is completely collated by hand by our domain-specialized curator on a daily basis. So our models are constantly updated and improved.
Which JANZZ application are you most involved in?
I am mostly involved in our parsing services, resumes and job descriptions, as well as performance reports and employer profiles in global HTML groups, and corporate training solutions can appear in multiple formats and writing styles. So we have to structure this information in a convenient way, which is why we have developed our own parser that is available in multiple languages for job description and resumes. The structured records can then be indexed into a database to do a statistical analysis to identify potential trends, etc. I think this product saves a lot of time for recruiters and HR specialists who have to filter hundreds of resumes for a single job offer or find exactly the right person with the right skill out of all employees worldwide for a specific training. And it also helps companies to store their data in an organized way. I also work in the development of the JANZZ classifier. This is a family of tools to classify, standardize, and annotate complex sets of occupation-related data, such as job titles, skills, functions, or industries. We cover over 100 official occupation classification systems, such as ONET, ISCO, ESCO, NOC, KLDB, ROM, among others, and more than 60 standardized reference systems. In addition, I am also in charge of the development of several customized B2B solutions for multiple JANZZ customers.
Speaking about machine learning, deep learning, and natural language processing, how do you think these technologies will evolve?
Deep learning is a rapidly changing field at the intersection of computer science and mathematics. The purpose of machine learning is to teach the computer to do various tasks based on data. Deep learning has become an important area of artificial intelligence because of its success in many different fields. The natural language processing field has also witnessed considerable growth over the last few years, owing to the affordable, scalable, and computational power, an increase in digitization of data, and the merger of NLP with deep learning and machine learning. I am confident that the future of deep learning and NLP will be every bit as diverse as in the past, and we will see some truly fascinating and, quite frankly, world-changing advances in the coming years. It's really a very exciting space.
Why do JANZZ machine learning and deep learning models achieve the best results in the market?
I think that one of the most important factors of why our solution achieves such a good result is because of the data quality. We manually collect data on a daily basis to enrich our ontology and to train our deep learning models. In the AI and deep learning field, your system will only be as good as the data that you have trained it with. So JANZZ's approach of strictly hand selecting only makes a big distinction, as we make sure that our systems are based on the highest quality data standards.
Which NLP and AI problems in the HR field have you already solved?
One of the biggest problems in today's HR sector is to have the information structured in a connected and usable way. In this sense, we have solved this problem at JANZZ by creating the most comprehensive ontological database of HR data in the world, which is available in multiple languages and involves millions of nodes and relationships. The ontology can be used as the basis for many different tasks, such as matching, statistical analysis, type ahead and auto-completion, skill suggestions, among others. Also, we have been able to solve the problem of precisely extracting information in job posting, candidate resumes, HTML profiles, etc. For this, we have developed the parser. This system involves NLP and deep learning models which have been trained on their supervised data to realize the extraction of occupation, skills, experiences, among others. The parser is also capable of assigning different granularity levels to the extracted entities, like, for example, the education level for a certain college degree. Also, the level of proficiency in any given skill, numbers of years of experience, etc. Additionally, the parser can solve the problem of sectionizing job description into several regions of interest, like, let's say, company description, requirements, duties, offer, application, etc. This is especially helpful for companies that want to store and display their job offers with a consistent structure.
Alejandro, thank you so much for joining us today. It was a great pleasure talking to you, and we hope to talk to you again on some other topics related to artificial intelligence, machine learning, deep learning, and natural language processing.
Thank you very much, Laura, for having me. I am glad to join you anytime.
In the next episode, we will talk about the challenges of comparing the education of candidates with employer requirements in online job matching. Thank you for listening, and goodbye.
If you want to learn more about HR technologies, subscribe to this podcast or visit our website, JANZZ.technology. You will find new podcasts every month. Thank you for listening.